Okay, welcome back and welcome to the penultimate episode of Amino Acid Mondays. We're going to be talking about some nitrogen-based amino acids. We're going to be starting with arginine. So arg for its 3-letter or just R for its 1-letter. Let's draw the structure out on the right as always. So this is going to be quite a long amino acid, as you can probably tell by now. It's got that chain of carbons there, and then it's got a really interesting functional group on its side chain. So this is the functional group there. This is actually called a guanidino functional group. So we're going to I'll spell it out, guanidino group. Also a guanidine, like so. So basically it's kind of like some amine groups stuck to a carbon there, and you've got that double covalent bond here, which will have some resonance features which we'll discuss. So its IUPAC name for arginine is 2-amino 5-guanidino pentanoic acid. Okay, so 1, 2, 3, 4, 5, so pentanoic. And then on the 5th carbon, there is the guanidino group, and on the 2nd one is the amine group. Okay, so it's got a pKa of about 12.5. So at physiological pHs, it's going to be positively charged. It's going to gain a proton on that guanidino group. Okay, so for resonance, there's actually quite a few things that can happen to this double bond, so you can kind of distribute it across any of these. So let's say that when we gain a proton, so we're going to gain a proton on this nitrogen here, for example. So this is going to be positive. And then we can also do the same thing, really. We can leave that double bond so that will cancel, or that will neutralize this amine, but then it will actually give a positive charge to that one, and we can also do the same thing for the last one as well. We can give that a double bond and a positive charge, which is pretty cool. Just a kind of a side note there. Let's get rid of this. Okay. Cool. So in terms of codons, there's actually 6 codons. These codons are CGU, CGC, CGA. This is a terrible G. I seem to just struggle with writing G's. CGG. And then we've got 2 AGs. We've got AGA and an AGG. Cool. And as this is similar to eggs, if you want to actually eat lots of arginine, because it is an essential amino acid, you can eat eggs or dairy products. So feel free to eat those and stock up on some arginine. Cool, let's talk about lysine now. Lysine. So lysine's 3-letter is lys, or its 1-letter is just K. Don't ask me why, it's just K. So let's draw out the structure. So this time the actual chain is quite a bit longer than that of arginine. It's actually got an extra carbon as part of its chain. So the functional group here is just an amine group, and if you're aware, amine groups are basic, so you can kind of class lysine as a basic amino acid. Okay, so its codons are basically pretty decent A-level grades, and the name of a Bollywood film from 1994. So they're the 2 codons for it. And it has a pretty important post-translational modification, at least it undergoes methylation quite frequently. And in histones, the methylation of lysine actually correlates to deactivation of transcription. So I'll put that as a note there. So the hypermethylation, so basically you can methylate this amine essentially 3 times, really. You can put 3 methyl groups or 2 methyl groups, and that kind of is known as hypermethylation. And finally, if you want to stock up on some juicy lysine, you can eat some fish. So it's actually in a lot of meats and fish, and it is an essential amino acid. Okay. And a fun fact about it is actually in Jurassic Park, all the dinosaurs are said to have their genetic code modified so they couldn't produce lysine. So this would mean that dinosaurs couldn't survive outside the park. But as I just said, it's an essential amino acid, so animals can't synthesize it. So actually, this isn't true. Childhood destroyed.